This question is of data sufficiency. Here two statements are given, statement 1 and statement 2, and we have to find whether these are sufficient to answer the question asked here in this question. That is, what is the probability of getting two pens, one Camlin and one Reynolds, from a box in which there are three types of pen: Camlin, Reynolds, and Rotomac. So let us write this way: Camlin, Reynolds, and we can represent Rotomac by O. Rotomac. We'll use only O. In statement 1, there are 25 pens in the box, and ratio of Camlin to Reynolds pen is 2:3, and number of any type of pens cannot be less than 5. So let us find what can be the possible arrangement. We have 25 pens in total. Let the Camlin pen and Reynolds pen are in ratio of 2:3. Camlin cannot be less than 5 because it is given none of them can be less than 5. So if we take Camlin to be 5, Reynolds will be 7.5, which is not possible because pen cannot be in fraction. So let us take Camlin 6, then Reynolds will be 9, and Rotomac will come out to be 9 plus 6, 15, 25 minus 15, 10. Let us check what are the other possible cases. Let the Camlin be 7, then Rotomac will become, Reynolds will be in fraction, which is not possible. So let us take Camlin 8. Reynolds will be 12, and Rotomac will come out to be 5. And if we increase Camlin here, Reynolds will also be according to that, and Rotomac will become less than 5, which is not possible. So these are the only two possible, and we can clearly see statement 1 is not sufficient to answer this question. What is the probability of getting two pens, one Camlin and one Reynolds? Because we have to find exact number of Camlin and Reynolds, but here or there we get two possible cases. So statement 1 is not sufficient. So let us check for statement 2. In statement 2, it is given that the probability of selected two pens one by one. First is Reynolds and second is Rotomac. It must be selecting. The probability of selecting two pens one by one, first is Reynolds and second is Rotomac, without replacement is 10. So let us represent Reynolds pen by R and Rotomac pen by O. So R, C, we have to find only one. O, C, 1 upon 25, C, 2. But because here the sequence is clearly defined, we have to divide this by factorial of 2, which is equal to 10%. That is 0.1. This is 25. We can write it as 25 into 24, 25 into 24 upon 2. So 2 will go up, and we can cancel 2 by 2 factorial because value of 2 factorial is 2 only. And we will shift this side, 25 into 24. 24 into 25 is 240, 480, 600. 600 into 0.15, we will get 60. Because this is RC1 and OC1, and R is number and O is number here. R into C is equal to 60. But there are various cases of R and C. There are various possible uh, numbers which can be R and C. 6 into 10 is also 60, 15 into 4 is also 60, 30 into 2 is also, but 30 is not possible. So statement 2 is also not sufficient. But if we combine statement 1 and 2, sorry, it is not C, it is O. We can see, well, R and O, there are only two possible cases, and which of them gives value to be 60? It is this case, situation number 2. 12 into 5 is equal to 60. So this will be the number of when 8, 12 and 50, and from this we can find the probability of getting Camlin and Reynolds pen. So statement 1 and 2 both are required, both are required. Both are required. Now if in question it is asked find the probability of, now here our question is completed. It is because it is only of data sufficiency. Now if in question, if it is asked what is the probability of getting one Camlin and one Reynolds pen, and we have to find that, we can do Camlin and Reynolds 8 C1 12 C1 upon 25 C2. This will give the probability. Here we will not divide it by 2 factorial because the sequence is not clearly defined as in statement 2. First is Reynolds and second is Rotoman. Here the first can be Reynolds or first can be Camlin, both is possible. So we will not divide because C which represents combination, it already includes these two situations. So we will not divide it by 2 factorial. It comes out to be 8, 12, 25 into 24 into 25 will divide it. It will come out to be 3.2. 3.2 will be the probability of getting one Camlin and one Reynolds.